Good morning. In this video, we are going to discuss about fixed bias. In last video, we have discussed about what is biasing and what is the importance of biasing. So this video will start with the first type of biasing, fixed biasing. So this is the circuit for fixed bias. So it has two resistors RB and RC with the transistor. There are two coupling capacitors C1 and C2. So first we will do DC analysis in this video, and the next video we will do the small signal analysis. So the main thing in DC analysis, while doing DC analysis, so what will happen now? What we have to do for the capacitor? While doing DC analysis, the main thing is capacitor. The main thing is we have to open the capacitor. You can see here the C1. This is the capacitor C1. Here I have removed the capacitor. So this C1 and C2 will be to open up C1 and C2. Now this is the DC circuit. For this circuit, you have to calculate from this DC circuit. You have to calculate the operating point. So I will redraw the circuit. This is base, collector, emitter, RC, VCC. This is RB. RB is also connected to VCC. The first thing is the current flowing through the collector terminal is, we know that is IC. Current flowing through the collector terminal is IC. The current flowing to the base terminal is IB. The current flowing to the emitter is, this is emitter current. Now, I will write in KVL as the input loop. So this is the input loop. So this is the input loop. To write the KVL at the input loop, you can see there is a VCC here. VCC. What is the meaning here? The positive, this is the positive of VCC is connected to RB, and the negative of VCC is grounded. So this is the meaning. The positive of VCC is connected to RB. And after this, so this is the other end of resistor is connected to the base terminal. So this is the base terminal. And after that, there is the emitter terminal. So here is the emitter terminal. The other end of the emitter terminal is grounded. So this is the input loop. So between the base and the emitter, there is a potential drop. We will call it as a VDD. So this is the complete loop. So the positive of VCC is connected to RB. The other end of RB is connected to the base. There is a drop between the base and the emitter. The other end of emitter is grounded. Now I will write a loop equation here. So the current flowing through RB is IB. This side is plus and this side is minus. I will write a loop equation. This is minus and this is plus. So I will write KVL with the sign of the entering sign, which is minus VCC plus IBRB minus VCC plus IBRB plus VBE equal to 0. So this is minus VCC and here it is plus IBRB After that, that is plus VB equals 0. From this, we can calculate what is IB. IB equal to VCC minus VBE divided by RB. Once you know IB, you can calculate what is IC. IC is beta IB. So from the input loop equation, we can calculate base current and the collector current. Once you know base current and collector current, we know what is emitter current. IE equal to IC plus IB. The next is we have to apply KVL at the output loop. KVL at the output loop. So the VCC is here. VCC, this is positive side and this is negative side. What is the meaning of the plus VCC is here? The positive of VCC is connected to the RC and the other end of VCC is grounded. So the positive of VCC is connected to RC and this is the collector terminal and this is RC. Here the other end of VCC is grounded. After that there is an emitter terminal. The other end of emitter terminal is grounded. So this is plus minus. There is a voltage drop between the collector and the emitter terminal. So this is a complete loop. So the current flowing through RC is IC. Now I will write a loop equation here. Minus VCC plus ICRC plus VCE equal to 0. So from this, what is VCE? Equal to VCC minus ICRC. So from the output loop equation, we have calculated VCE. Now we have to draw the load line. This is VCE and this is IC. So this is the load line. Now I have to calculate this point, a point on the x-axis and the point on the y-axis. To calculate the point on the x-axis, we can make y-axis to be 0. So from this equation, VCE equal to VCC minus ICRC. So in this point, IC is 0. So first, let me make IC is 0. If IC is 0, VC is equal to VCC. So this point is equal to VCC. Because a point on the x-axis, y-axis must be 0. So IC is 0. By making IC as 0, VC equal to VCC. Similarly, I want to calculate this point. To calculate this point, I have to make VCE to be 0. So VCE next is VCE is 0. If VCE is 0, what is IC? IC equal to VCC by RC. So here IC equal to VCC by RC. We have calculated the endpoints. Okay. Now to this equation gives VCQ. This Q represents the Q point. VCC minus ICQ RC. So ICQ is from this ICQ which is beta IBQ. ICQ is beta IBQ and IBQ is VCC minus VBE divided by RB. Once we know the values of VCC, VBE and RB, we can calculate what is IBQ. If we know the value of beta, we can calculate ICQ and then we can calculate what is VCQ. So this Q point is VCQ, ICQ. Okay, so this is how to calculate the Q point of a fixed bias circuit. In the next video, we will do the small signal analysis for the same circuit.